Question. In a children's story, a princess trapped in a castle wraps a mastid around a rock and throws it from the top of the castle. Right next to the castle is a moat. The initial velocity of the rock is 12 meters per second. The direction is 42 degrees above the horizontal. The rock lands on the other side of the moat at a level 9.5 meters below the initial level. Air resistance is negligible. A. Calculate the rock's time of flight. B. Calculate the width of the moat. C. Determine the rock's velocity on impact with the ground. We set the 0 point at the starting point of the rock. So this is the 0 point. This is also the starting point of the rock. And this direction is positive y direction. This direction is positive x direction. And this is the initial velocity. The initial velocity. And this angle is 42 degrees. And here is the landing level. Here is the landing level. Then the rock would follow a parabola curve, go like this, then falls down to the ground. And this distance, so the vertical distance from the starting point to the landing level is 9.5 meters. So we know the initial velocity is 12 meters per second. And theta, the angle between the direction of the initial velocity and the horizontal level is 42 degrees. And its vertical displacement is negative 9.5 meters. It's negative because its displacement is this direction. It's opposite to the positive y direction. Now question A. It asks for the time of flight. So it's the time interval. And we start from here. We know this formula. The final vertical velocity square equals the initial velocity multiply sin theta, this square, then minus 2 multiply acceleration g multiply the vertical displacement. So the magnitude of the final vertical velocity just equals square root the initial velocity multiply sin theta square minus 2 multiply g acceleration multiply the vertical displacement. Now this equals square root. The initial velocity is 12, so 12 multiply the theta is sin 42 degree square. Then minus 2 multiply the acceleration 9.8. Then multiply the vertical displacement negative 9.5. Then this equals 15.83 meters per second. This is the magnitude of the final vertical velocity. Then the final vertical velocity equals negative 15.83 meters per second. It's negative because its direction is down. At last it falls down. Its direction is down and it's opposite to the positive y direction. And we get the final vertical velocity. Then we know this formula. The final vertical velocity equals the initial velocity multiplied sin theta minus acceleration g multiply time interval. From this formula, we can get that the time interval just equals the initial velocity multiplied sin theta minus the final vertical velocity over the acceleration g, and this equals, so initial velocity 12 multiplied sin 42 degree minus negative 15.83 meters per second. The bottom is 9.8, and this equals 2.43 seconds. So the flying time is 2.43 seconds. And the question B, it asks for the width of the moat. So in fact, it asks for the horizontal displacement. We know this formula. The horizontal displacement just equals the initial velocity multiplied cosine theta multiplied time interval delta t. And this equals, it's 12 multiplied cosine 42 degree multiplied time interval 2.43. Now this equals 21.67 meters. So the width of the moat is 21.67 meters. Now question C, it asks for the final velocity. So we can find the final horizontal velocity and the final vertical velocity and use them to get the final velocity. So we know the final horizontal velocity equals the initial horizontal velocity and equals the initial velocity multiplied cosine theta. So this equals 12 multiplied cosine 42 degree and equals 8.92 meters per second. This is the final horizontal velocity. Its horizontal velocity is constant. The initial horizontal velocity is the same as the final horizontal velocity. Then for the final vertical velocity, we already got it. This is negative 15.83 meters per second. Is here. Then I draw them. This is the final horizontal velocity, and this is the final vertical velocity. Final vertical velocity. Final horizontal velocity. And this is just the final velocity. This is a right angle, and this angle is theta. So from the graph, we can know that the magnitude of the final velocity equals square root the magnitude of the final horizontal velocity square plus the magnitude of the final vertical velocity square, and this equals square root 8.92 square plus 15.83 square, and this equals 18.17 meters per second. Then the angle theta equals arc tangent. The top is the magnitude of the final vertical velocity. Bottom is magnitude of the final horizontal velocity. Now this equals arc tangent. Top is 15.83. Bottom is 8.92. and this equals 60.6 degree. So the final velocity is magnitude 18.17 meters per second. The direction is 60.6 degree below the horizontal.